Right, am I audible? I think you can hear me, right? So last day we last day I given you this worksheet that is about descriptive statistics and data visualization, right? So the first thing is, so you need to add this data to the SPSS worksheet, right? For that you have to define these variables. So you can see here. Student ID, age, gender. There are scores for three subjects, math, science, and English, and then attendance. So for these things, we need to create the variables. So you can see here, student ID is a nominal variable, right? It's a nominal variable. It is we are using for naming purpose, right? Then it is a nominal variable, right? This is nominal variable. Then age. Age, again, age is a scale variable, so we can take age for calculations. And gender we can here, I added gender as a string. Y, M for male and female. Uh, Here, yes, just added male and female with name. So if you need, you can, here I just add as a string, just added male, female. If you want, using these values, you can assign F and M for male and female. It is also possible. Then math score, science score, English score, those things are those things are scale variables, right? Scale variables. Uh, right. And attendance, again a scale variable. Then we can add this data. Okay. We can add this data by looking into this table. I think we can add those things. Next, we can next after adding this data, we can go for the analysis. First one is calculate the mean, median, and mode. It means descriptive statistics, measures of central tendency. So when we are doing an analysis, so we have to find those things. So therefore, at once we can find this mean, median, and mode for this science, age, everything. So we can go, the path. Uh, we can go analysis, and analyze, descriptive statistics, descriptives of frequency. Right, I can go for frequencies. Then I need to select math core, science core, age, English core, and the attendance. Right, I want to select age is also there. Yes, age is also there. Age, math core, science core, English attendance. Then we can take this for the variables column. Right. Then what we need to find is we can go for the statistics. So we have to find mean, mode, median. Mean, mode, median. That's all. Then we can continue. We can continue then. Okay. We can see the output here. So mean of age 24.65, median of age 24.50, mode is 20, right? Mode is 20. And for math score, again, mean is 77.70, median is 79.50, uh, mode is 57. Likewise, we can take this output for the first part of for the first question of the tutorial. The second one is calculate the range, variance, and standard deviation for same variables. Again, so the thing is just again you have to find standard variance, standard deviation, variance, and those things. Standard deviation, variance, and range. We can go from a same path analysis. descriptive statistics, frequencies, right? Now we can go for statistics again. Now we need these three. This is measures of central tendency. Now they are asking about measures of dispersion. So in under here we can select range, standard deviation, and variance. Then continue, click OK. Then it is displayed those things. Then standard deviation of age is 3.345. Variance of age is 11.187. Range is 11. Right, for med score, a standard deviation 12.599. Variance 158.747. Range is 44. Right, likewise, we can find these things. Then for third one, create frequency table for attendance variable and interpret the results. So then we have to create a frequency table, right? Frequency table. Yeah, there are two types. Yeah, so then we can create frequency table. Again, we can go the same process, analyze, descriptive statistics, frequencies. Now we have to create frequency table for only the attendance variable. Attendance variable. We can take these for the other side, then display frequency tables. Only frequency table it needs, right? Frequency tables. Then this is the frequency table. There are 20 inputs here. We can see frequencies 68, 1, 81. Likewise, we can create a frequency table. But once we think about frequency table, so we have uh, always we are thinking about the table with class intervals. Class intervals විදියට තියෙනවනේ අපි ගොඩක් වෙලාට බලන්නේ. So in here, so in this SPSS, there is no direct options to create that kind of table. Anyhow, so but we can do it, right? So if we need that kind of, it means we can create. I will show you how we can create that kind of table, right? I think it is in data. Visual binding is where transform. Yeah, it is in there, right? So if you need a frequency table like with class intervals, I think you remember that. So how we can create that frequency tables? 68 to 82. How many? Uh, what is the frequency? Likewise, we can create a table. So that is for that table we call frequency table, right? But in SPSS there is no direct option to create that kind of uh, frequency tables. Anyhow, we can do it. Before that, we have to create another table. We have to create another table, sorry, another variable. So I am going for the transform visual binding, right? Remember it. I am going to use a simple trick, actually. Simple trick to make a frequency table. So they transform visual binding. Then you can see I want to uh, create uh, frequency table for the attendance. Therefore, I will take attendance here, right? Variable to bin, then continue, right? So current variable is attendance. So bind variables I will take as attendance, attend bind, right? Attend bind. Then yes, okay. Then I can go for this make cut points, right? First cut location. So the minimum value is 68. So I can start from 65, right? I will start from 65. That is class intervals. Then this is close to 102.29. Therefore, a number of cut points. So end point, we can number of cut points and width. Width I can take as 5. With 5, then number of cut points. Its last cut point is number of cut points 7. It is not enough. Maximum 98. The last cut point location is 95. That's no, it's not enough. So we have to take eight cut points actually. Then 100. 102. It is also not enough. Nine, right? Then it's come 105. It's okay now because uh, 68 to 102.29. So that should be the class interval range, right? So we can take like then apply. So then we can make labels. Then here you can see for 65, 65, 66 to 70, 71 to 75. Likewise, we can make these uh, values, right? So I will explain it again. Then I'm canceling this one. Discard changes, no. Sorry, cancel, discard changes, yes. I'm starting again, right? We can go for transform visual binary, visual binary, right? Then I have to take attendance, then continue, right? So now I have to create new variable attendance, attend, bind. That is the new variable. Then I have to make the cut points. So therefore, for that I am checking this one. So this the minimum number is minimum is 68. So therefore I am going to start from 65. Then I know the maximum. I don't know about the maximum. So then I can create a width. I'm going to take as class size 5. So I will add 5 there. Then automatically it gives number of cut points and the last cut point location, that is 95. But it is not enough because their maximum is 98. Maximum is 98. I think then therefore it's not enough actually. Therefore, what we can do is I can add now another number, another cut point, 8. Then last cut point location is 100. So I will see what is the maximum actually? Uh, Maximum of the attendance. Yeah, 98%. Yes, 98%. Then it's enough actually. Last cut point location is 100. Okay. Then we can apply. Then here we can write make labels. Then it's come as 65, 60 to 70 likewise. Then I can press OK. Binding specification will create one variable. Yeah, then after open visual binding, another variable is created. Then here it's mentioned that it is record to values. So we can go for the data table. You can see another table here. It's called attend bind. Right. So, but we don't know what are the values there actually. Right. Anyhow, that we can create this one. Then now we can create a data table that actually frequency table using the same process. But then earlier, how I create the table, I took that attendance as my variable. Now I am changing the variable attendance to attendance bind. Attendance bind. Now okay. Now you can see what happens. Earlier you got this frequency table. Now it's changed to this one. Here. Now it is 66 to 70. The frequency is 1. 76 to 80. Frequency is 1. Right? Then 81 to 85. Frequency is 3. Likewise, we can take this frequency table. Right? I think you got it. So then if you need to create this kind of table also, it is possible in SPSS, but we have to use a trick. So we have to create another variable called bind variable actually. Bind variable. Okay. Next one. Next question is data visualization. Create a histogram for med score, bar chart for gender distribution, and scatter plot for showing relationship between attendance and med score. Right. Mm, First thing is I want to create a histogram for med score. Right. I will try using this one. Analyze descriptive statistics. Then again, raise hand. Any question? Amira, do we have any question?
Good evening, sir. We
Yes.
have to use that attend binding or something.
Sorry, I couldn't get it.
Hello, sir.
Oh,
Sir, when we have to use this attend binding bind,
කොහෙටද use කරන්න කියලා දහන්නේ අමිල?
oh, sir, we are when to use again कोई वගේ අවස්ථාවක සමයක use කරන්න කියන එක.
right. මේ bind yeah visual bind use කරන්න වෙන්නේ අමිල වෙන්න මේ දැන් මම මේ කිව්වා වගේ purpose වලටම තමයි because now here that the method then I previously I created a frequency table, right? Frequency table. But for this attendance, right? Look at here. Then it's given. There is 168, 180, 182, right? 184, likewise. So, so when we consider this as a frequency table, it is actually not. It is not like a frequency table because it's the make it then if you have many data, right? So many data like us. Then here you can see only 20. But so in frequency distribution, so you can see then if you uh, collect data from 500 participants, so you have 500 entries. So if we need to take some, if you need to create I mean, frequency table, right? Frequency table, sometimes there are 500 entries if you create a table like this, okay? But so in that cases, we have to create the table with class intervals like this. 66 to 70, how many participants? 66 to 70. Actually, only 68 is there. Then here one frequency is one. Then next class interval is uh, uh, 76 to 80. Then how many variables are there? Likewise, so we can create this. Okay, we can see here. Then how it is to make this one, we can't use directly because there is no option in SPSS. That's why we have to create a new variable called um, here. We can create new variable, uh, bind variable. So that for that thing, so we have to use the visual binding option. මේ වගේ අවස්ථාවලට visual binding කියන option එක use කරන්න. ඊට පස්සේ then when we are creating the frequency table that uh, instead of using this attendance, so we can use attendance bind variable like this. Attendance bind variable, then it's generate this after using this attendance bind variable, it's generated that frequency table. So therefore, that purpose we have to use this visual binding, uh, option. Is it clear, Amila?
So yes, sir. That will be only
Yeah, it will be only for this kind of
nominal
purposes. Otherwise,
data
yeah,
only, right, sir? Genders.
yeah. I'm not clear with the problem, right? හරියට ඇහුන්නේ අමිල. ඒ කියන්නේ මේ problem එකක් මේ what you call මේ network
Sir,
problem
මට
එකක්.
දැනගන්න
ඔව්.
සර් කනෙක්ෂන් පොඩි ඉෂුවක් තියෙනවා සර්. යාළුවෝ
ඒක
සර්.
තමයි.
මම ලංකාවේ නෙමෙයි සර්. මේ
Okay.
ප්‍රශ්න තියෙන සර් දැන් විෂුවල් බයින්ඩින් කරන්න තියෙන නොමිනල් ඩේටා වලට විතරද? දැන් අපි සාමාන්‍යයෙන් ගත්තොත් අපිට දැන් බැරි දේවල් තියෙනවනේ බෙදන්න බැරි දේවල් සර්. ඒ කියන්නේ ඔය තියෙන
Yeah.
අපි දැන් 5 point ලිකට්ස් දෙනවල් අන්න ඒවට එක දාන්න බෑ නේද සර් සාමාන්‍යයෙන්. ඒ කියන්නේ ස්ත්‍රී පුරුෂ
Yeah. Yes. Yeah.
or
Yeah. 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 Yes.
preferences වගේ ගත්තා
Yes.
වගේ.
Yeah. That's true, Amila, because then here that it's very good question because this one is that when we are categorizing, actually, that should be uh, should be in the scale or ratio or monkey with scale or uh, ratio or scale what we call no scales actually, right? Otherwise it cannot be used if those are in otherwise we don't need here, right? මේවා ඕන වෙන්නෙත් නෑ මොකද එහෙම අපි කරන්නේ දැන් අපි හිතමුකෝ weights තියෙනවා, there are some weights of participants, so we have to create that frequency table with how using this actually like this kind of um, frequency distribution. So for that purposes only we can use actually if the variables are that ordinal scale, nominal scale, actually nominal scale variables sometimes, but if the variables are in ordinal scale, like as you said, so strongly agree, so strongly agree in that kind of thing. So we can't use this bind options. Yes, that's true. Yeah. Okay. Uh, then
Thank you so much.
next one is data visual. Yeah. The next one is data visualization. Create histograms for Matsco bar chart for gender distribution. So we can go for first we can draw histogram. I will try. There are several options. I will try using descriptive statistic frequency. I didn't remember actually it is in there. Yeah, charts is available here. Charts. Bar charts, pie charts, histogram is there. But if we can't use here, we can go for the option called graphs. Here you can see separate tab for graphs as well. So first we'll try in here. If it is not successful, we can go for graph. Right, then here what we have to do, create histogram for Matsco. Here Matsco is there. So I can go for charts. Then I want to create a histogram, show nominal, no, normal curve also. Then continue. Okay. It takes some time, right? So we have to wait until it produce uh, the histogram. We'll wait a while. Frequency variable is Matsco format, but it will produce. So still the output is not there, right? We'll wait some time. If not, if this is not successful, we can go for this one graph. That is one method. It also gives the graph. So we'll wait later on. It gives the graph after some time. Then we can go for graphs. The other option is we can go for graph here. Then legacy dialogues, graphs, legacy dialogues. Then we can go for histogram from here. Then yes, then now it's produced the graph. Yeah, it takes some time actually to produce the graph. Yeah, that is it graph given by using this analysis option, analysis descriptive statistics, frequencies. Then here we have the option for charts. From there we can take the histogram. Or the other type, other ways, and graphs, legacy dialogues, histogram. Then our variable is again, what is the variable? Matsco, I think. Matsco, yeah. So then I can take Matsco for variable, display normal curve, press OK. When it is, if you use the graph, uh, then here it's come under frequencies. If you use the graph tab, it's produce the histogram very quickly than this one because this takes some time, but same curve, this will produce uh, quickly. So if you use the graphs, legacy dialogues, but uh, final output is same, right? But two methods, right? So you can use any method you like. I think it's better to use the graphs because it will produce the final result very quickly, right? So the second question is bar chart
Yeah.
for gender distribution. Bar chart for
Okay.
gender distribution. So again, I will use both methods. Then first one is analysis, descriptive statistics, frequencies. Then go for charts. Uh, Bar chart for gender distribution. So I have to go for the gender, then charts, bar chart, right? I'm going to use bar charts, then okay. Bar chart produced here. Yeah, yeah. Then gender for gender distribution. So there are 10 male, female, and 10 male. That is equal actually. So we can take the output like this. Amil, again, do you have a problem?
Sir, kindly tell me what is denoted by the bell shape, sir. Why that bell shape is
Yeah.
coming?
Yes, yeah. Okay. Right. I think you have the idea. So, yeah, right. So the bell shape is that. So when we are, I think it is. We will wait. I think it is in today's one, if not, no, no, it is not in there. Right, bell shape means, I think I told you in the last time as well as I remember, right? So if we consider a distribution, right, to perform there are two types of data. One type is parametric data, the other type is non-parametric data, right? So the first thing is, so today we are going to use some non-parametric test, right? So if before conducting any test, so we have to verify our data is normally distributed or not, right? Normally distributed or not. For to check that, there are two tests. I explained you. One is Shapiro-Wilk test. The other one is Wilcoxon sign. Sorry, Shapiro-Wilk test. The other one is Kolmogorov-Smirnov test, right? So we have to do those tests before uh, conducting any parametric test. So the normal distribution is for the parametric data. So uh, if this data appears in this curve, normal curve, we can say this data is normally distributed, right? So mm, right. So then the meaning of this normal curve is, if these data under this curve, we call those data is parameter under the normal curve. It means it is we can use the parametric test like t-test, then ANOVA. Today we are going to talk about t-test and the ANOVA, uh, and regression. Those things we can apply for uh, parametric data only. That's why we are checking these data under the normal distribution or not, right? So I think it is on last day. Right. Here we can see, uh, we can check whether this data is normally distributed or not. So we can check, we can go for analyze, descriptive statistics, explore, right? Analyze, descriptive statistics, explore. Then I will take one Metsco. Then we can go statistics. Not this one. We can go for plots. Yeah, we can go for plots. Then normality plots with test, right? Then continue. Normality. So we can go analyze, explore, right? Then we have to check the dependent variable. Then we can go for the plots. Then normality, test with plots. So if you like, you can draw this histogram again from here, right? For math go. Then okay. All right. So you can see here the test of normality, then it's produce these tables, histogram again, right? So the most important thing is we can go for here. Yeah, right. If the data type, the number of data more than 50, we can go for the Kolmogorov-Smirnov test. So then here number of data is 10 in sorry 20. 20 is less than 50. So we have to check this Shapiro-Wilk test. So you can see here significance value, this value. What is this value? This one. That is 0.209. Based on this, we can check the normality of our data set. Then here 0.2. If this value is greater than 0.05, right? The value, if the value, for this value, we call significance value or p value, right? Significance value or p value, right? For this, we call p value or significance value, right? Significance value. If value is greater than 0.05, right? In these two tests, in these two tests, what are the tests? In these two tests, test are test of normality. These two tests. One is Kolmogorov, I don't know its spellings, Kolmogorov and Smino test. Or the other test is Shapiro-Wilk test. Shapiro-Wilk test, right? This value is greater than 0.05. It represents that data set is normally distributed. If that is normally distributed only, if that is normally distributed only, we can use this data set for the parametric. If this is normally distributed only, we can use can be used parametric tests, right? Like t-test, ANOVA, ANCOVA, MANOVA, regression, right? So, right, regression. So, if not, we can't use this data for parametric analysis, right? So the thing is, first, what we need to do, we have to check the normality of the data set. So now to check the normality of data set is there are many methods actually. So one is this using this QQ plot, then data should be spread you approximately like this line, straight line like this one, then it is normally distributed. Then easiest method is this one using this test. So you have to check only the value, not the shape. Sometimes if we are going to observe the shapes, it may be give some wrong results because we are taking by looking at to the some figures, but uh, this is better actually. So we have to check this value. If it is greater than 0.05, I guess with the that data is normally distributed, right? So then that is, if it is normally distributed, that is come under the normal curve. Therefore, we can use this uh, parametric test. Okay, right. Then next thing is, now we draw bar chart for the gender distribution. So um, there is another way to draw the bar chart. I think I used one method that is in here. Then, or we can go for the graphs, legacy dialogues, then bar chart, simple bar chart, or clustered bar charts. We can. Then other variable is what is a variable like mat score? No, bar chart for gender distribution. Bar chart for gender distribution. Gender can go for here. Okay, then we can take the graph. Yes, female again, male again. As same as graph is same, but there are two methods to draw it. Next one is a scatter plot. Scatter plot. This I think scatter plot is available only this option, legacy dialogues, but we'll try here. We can go for analysis, descriptive statistics, descriptive statistics, then frequencies, then we can go for charts. Now I am going to draw scatter plot for attendance and math score. So I will take attendance and math score. Then I can go for the charts. There is no option for uh, drawing a scatter plot here. Then using this frequencies options, we can't use. We can draw this mm, charts. Therefore, I can go for the other option, graphs, legacy dialogues. Then I want to draw a scatter plot, scatter or dot plot. Then simple scatter I can draw. Then axis, y-axis and the x-axis they ask. So what we have to draw scatter plot showing the relationship between attendance and mat score. So therefore, I will take attendance for x-axis, mat score, yeah, mat score for y-axis. Then that's okay. Then okay. So this is the scatter plot. It will produce the scatter plot. So how it's right, how that is spread. So we can use the scatter plot to see the correlation between two variables actually. Right. Next one. Based on your graphs, answer the following questions. Insight from the yeah, you can answer for these questions. Actually, this is how we have to interpret, right? What insight can you derive from the histogram of mat score? Yeah, histogram of mat score, what you can see here. Yeah, this is a histogram. So after drawing this one, so you can see this is highest one. The frequency is 4. 4 score 90, right? There are four students who scored 90, right? So that is the maximum one. Then minimum one is this one. Likewise, we can express. You can actually you can interpret the data in this histogram. But what does the bar chart reveal about the gender distribution? Yeah, so we can go if we go for this bar chart. What we can reveal is we can see there is equal gender distribution in my sample. Why? Because number of males and females are equal according to this bar chart. And is there any trend between mat score based on the scatter plot? Yeah. So we can go for the scatter plot. Are there any trend? No, we can't see. So if it is spread like this straight line, we can see there is a positive correlation. But in here, yeah, it's no trend we can see actually. We can't draw actually a line for this side or this side. Therefore, there is no trend. So we can't predict that. Okay, then this one. Uh, yeah, we discussed last time this split file option. Analyze mat score by gender and interpret these findings. So then now we have to split the file uh, using the variable gender. Then I want to present the statistics. So for these descriptive statistics separately for males and females, right? Separately for males and females. Therefore, I can go for the option split file, data, split file. Here, data is split file. I want to split file by gender, right? By gender. Then I can take gender, organize output by groups. The uh, variable is gender. Then hit OK. Then we can see short cases by gender. Now we can perform what is our requirement, mat score. Yeah. Then I am going to find the descriptive statistics for the mat score. Descriptive for the mat score. Then OK. Then what happens here? It's producing males and females separately. So you can see here there are 10 males and 10 females. Then minimum mat mark of uh, female is 51, male is 57, maximum is 92, here 95. So mean is 77, and here if you consider male, 78.1 mean score. Likewise, we can uh, take this table separately if you use the split file option. Now, after doing this analysis, now in this point forward, so because we split the file using by gender, if we didn't turn off this, all the analysis after this point is produced uh, separately by male and female. Therefore, if we don't want to take the outputs anymore by separating to the gender, separating males and females, what we need to do is we have to change, we have to turn off this split file option. For that, we have to go from the same path, data, split file, then we have to turn off analysis all cases do not create groups, then okay. Now here mentioned that split file off, right? Here I mentioned split file off. Okay, now again we can take the analysis for this whole group, whole set of data, right? That's okay. Next one, use compute function in SPSS to create new variable called total score by summing math, science, and English score, right? Then next thing is we have to take a variable called total score by adding math score, science score, and English score by using this command, compute variable function. Yes. So what we can do is we can go transform compute variables. Transform compute variables. I need the target variable is total score. Total score. How I have to take this total score? By adding these three marks, maths, science, and English score. So therefore, I can take maths score from here, right? Click on this one. Then addition. Here you can see addition is there. Plus maths score plus science score plus English score. So this is my numerical expression. So the total score equals to math score plus science score plus English score. Now, okay. Now new variable is created, total score here. Total. No need of decimal points. Therefore, I remove these decimal points. Now we can see this is the total score by summing these three values. 51 plus 94 plus 58, it is equals to 103. Likewise, we can do any calculations using this compute variable command, and we can make new variables as well. Right, next one. Now it's okay. Then perform record into a new variable categories attendance into three groups. Low, below 80%, medium, this one. If it is greater than uh, 90, uh, we have to present it as high. Okay. So we have to go record into new variable command. Transform record into different variables. Record into then what we have to consider attendance. Therefore, input attendance is here. Attendance. Then output variable is I write attendance percentage. Attend percent. Then I will attend label attendance percentage. Okay. Change. We can change this. Now I'm going to change attendance to the attendance percentage. But there are some conditions because we have to create low, medium, and high. So therefore, I am trying low is 1, medium is 2, high is 3. These values I am going to assign for this variable at 10%. Okay, then we can go for old and new values. Now, old and new values. So if it is below 80%, so the lowest true value, that is 80. If it is less than 80, if it is below 80%, so what we need to do is, uh, I am going to put 1 there, right? 1 is for low, one I am going to record for what? Low, low attendance. Therefore, value is 1. Right? The value is 1. If the range that percentage is less than 80, then I can add lowest through 80, that is 1. Then later on, I have to define what is 1. Then next one is between 80 and 90, that should be recorded as 2. Okay, then for that, I have to go for range between 80 to 90. I am going to record as 2. Then I will define 2 later. Then I can add. Next one is high. If it is greater than 90, so I have to record it as high. Therefore, highest true value. Yeah, ranged value through highest value, that is 90, value is 90. Then I want to record this as 3. Then add. Now we can continue. Then okay. Then new attendance percentage, new variable is created, right? So that is present as 1, 2, 3. But I didn't define what is 1, 2, 3. Now I can define in here. What is 1? 1 is low attendance, low, right? 2 is, what is 2? It's given medium attendance. Medium is 1. 3 is high attendance, right? Now it's finished. Okay. Now it is recorded in data review 1, 2, 3. Then, right, if you need, so we can find so how it is, then analyze descriptive statistics, uh, frequencies. Then I am taking this one, what is attendance percentage. Then okay, sorry, uh, analysis, analyze descriptive statistics, frequencies. I need not chart, none, right? I need frequency table, right? Frequency table. Yeah, that is now frequency table. Low attendance 2%, medium attendance 8%, and high attendance 10%, all the totally 20. Likewise, we can find when we categorize these into these ranges. Interpret the results and discuss the implication of advanced level on students' performance. Right here. Okay, I think that is actually how to find simple. We actually this is not actually for the prediction. These are the advanced statistical analysis. Today we are going to talk about this advanced statistical analysis. Then here, how we can find these descriptive statistics and the other things, right? Right. Now we can move for the today's part. We are going to discuss about. Let's see. I will close this. The unwanted things. Can close this one. And keep this close. Yes. Now today we are going to talk few analysis parts, right? Then t-test. So there are three types of t-test, and I will explain for where to use these t-test, called one sample, paired sample, and independent sample t-test. So in this presentation, so you can see here, then I mentioned how we can calculate. So, and but I'm not going to talk how we can calculate this using manual calculations. Anyhow, if you are interested by using the formula, here mentioned the formula, so you can use that formula and uh, calculate uh, t values and the other things manually, and you can check if that is uh, tally with the SPSS output. So if you are interested only, but here I mentioned, so these are the learning outcomes for the today's, for this unit actually, lesson 5. Right. So there are three types of t-test, right? What is t-test or student t-test? Assess the means of two samples. Two samples are significantly different from each other. So actually, we can use t-test for compare two samples only. If there are more than two samples, we can go for another. We can go for another test. So in here, we can compare using t-test only two samples. You have to remember that in mind. If there are more than two samples, we can't compare using t-test, right? So the question in t-test is addresses whether the means are significantly different or not. It means, so actually this is a mean comparison method. So here you can see x bar 1 means uh, mean of the first sample. X bar 2 is mean of the second sample. So suppose then here we got mean as 20, here mean as 25. So we can see there is a little bit change, but sometimes we can't say that is very, actually we have to find whether that change is significantly different or not. For that we have to perform t-test, right? So we can't just, if they are if that is 20, mean is 20 and here mean is 25, just we can't say that means are different. So for that we have to use for statistical analysis, right? To compare two means, we use this uh, sorry, t-test. right? There are statistical data analysis for the t-test. This I told you there are some formula. Omit that just for your knowledge. Once you receive this uh, presentation, so you can, if you are interested only, you can go for the manual calculations by finding. So there are many resources available, so you can use this formula. You can try if you want only, right? Because we can find these values using SPSS and the other uh, programs very easily, right? Yeah, three types of t-tests are available, right? There are three types of t-tests, so you have to remember that in your mind actually. You have to select which one is appropriate to your test. It is not day three t-test. Yeah. There are three types of t-test. One is compare the means of one variable of two groups of cases, right? So if there are two independent groups, for an example, uh, suppose you are conducting research. If you are a teacher or related to the education field, you can apply new teaching method as an experimental study. So you are going to check whether my new teaching method is successful or not. But for that, we can use this independent two sample t-test, because there should be two samples. It means if it is an experimental research, there are two groups. One is called experimental group, the other one is control group. So if you need to check whether there is a significant difference between this experimental group and the control group, what we can do is we can use this independent sample t-test. Independent sample t-test, right? So independent sample t-test used to check mean difference between two groups, right? So two groups means experimental and control, like this. So you have to keep this in your mind. Actually, the thing is that, so doing this, what we call taking the values from this using this software is not uh, a very difficult thing. But the thing is, you have to identify appropriate test to perform to take the output. That is the important thing, actually. So you need to identify which test is suitable for which. Mm, yeah, which say to do some analysis, right? So that thing is, then here, if there are two independent groups and we need to compare whether there is a mean difference, the test is independent two sample t-test. Remember it, right? To compare two groups, we have to use independent sample t-test. Right. Second one is paired sample t-test. Paired sample t-test. Compare the means of two variables for the single group. So within one group, in two occasions, sometimes we have to compare. For an example, again, if we are taking related to the education field again, right? So before sometimes you are going to do a research again. You are going to test a new teaching method, right? So before teaching to the selected group, you can give a test. We call that is pre-test, right? Then you can do your intervention. So you can teach to your students using new teaching techniques. Then after teaching that part, again we can give another test called post-test, right? Then we can compare whether there is a difference between the marks of pre-test and the post-test. To that, because we selected the same group of participants to the pre-test and the post-test. But in the previous case, if we are using the independent sample t-test, so we have two independent groups called experimental group and control group. So that is two different groups, right? So in that case, we can use the independent sample t-test. But here the difference is we are given the pre-test and the post-test for the same group of participants, right? So if we are testing same participant two times, it means same sample more than one time. Pre-test, post-test. Likewise, we have to use for paired sample t-test. Sometimes we call dependent t-test, right? Then second thing is then what we need to remember is that uh, paired sample t-test is where to use paired sample t-test is where to use compare two times in same group. Like if we can easily right pre-test and the post-test, right? If we have pre-test and post-test in same group of participants, we can use this paired sample t-test. Paired sample t-test. For another example, I can say, so suppose you are going to measure the successfulness of a weight. uh, So there are some programs, exercise programs. So I'm going to check the successfulness of exercise program, right? So therefore, before participating to these exercise sessions, we can measure our weight. And so suppose there is a group of participants to that exercise course. Suppose that is a Zumba class or something, right? Before participating uh, to that exercise program, we can measure the weights of the participants and record it. Then we can participate into the exercise program. So after participating sometime 1 or 2 months, again we can check, we can measure our weights, then we can record it. So then we need to check whether my exercise program is successful or not. So for that, so we measured two times same group of participants before the exercise program and the after the exercise program. It means pre-test and the post-test. In that case, we have to use the paired sample t-test. Can you understand where to use this independent two sample t-test and a paired sample t-test? So you have to understand it. If not, if you are going further, you are in trouble when we are doing analysis of your research. Any question? Can you understand where to use it? I think yes. There is another type of t-test that is we called one sample t-test. It means one sample t-test compares the means of one variable with the known or hypothesized value. Descriptive statistics for the test variables are displayed along with the t-test. So, then if we compare with the hypothesized value or a known value, for an example, again related to the education field. So if you need to check your class students' results are above or it means whether if there is a difference between mm, national level score, national level marks with my school marks. So we can use, suppose average of the national level marks of the mathematics subject is 62, right? 62. Then we can check, compare with that value 62. Whether there is a difference between the hypothesis value is not, it means a constant value. So if you are checking with a constant value, we can go for this one sample t-test, right? Right, we can take independent sample t-test. I explain where to use it. Right, there is an example, right? Suppose we uh, put people on two diets, the pizza diet and beer diet. These are the two different diets. One is pizza, the other one is beer diet. The participants are randomly assigned to either 1 week of eating exclusively pizza or 1 week of exclusively drinking beer. This is the research. At the end of the week, we measure weight gain by each participant, right? So then now here, actually, there are there are two groups, right? Two instances actually. And there are participants randomly assigned to either 1 week eating exclusively pizza. So one group is eating pizza for 1 week. The other one is drinking beer. So we need to check whether there is a difference between weight gain of these two groups, right? So then it means we have two independent groups. One assigned to eating pizza, the other participants assigning to drinking beer. So then we need to check whether there is a difference between the weight gain. Okay, right. Then, so when we are doing a hypothesis testing, when we are doing an hypothesis testing, the thing is that so we have to write the hypothesis, right? We have to write the hypothesis. So here you can see uh, in this one, right? In this example, uh, there are two groups. One is called uh, beer diet taking group. The other one is uh, pizza diet. So our there are two hypotheses called null hypothesis and the alternative hypothesis, right? So therefore, we have to write the null hypothesis and the alternative hypothesis in this manner, right? So we can write there is no significance difference. So that is the way of writing. Your sentence can be started using this phrase always when we are writing writing a hypothesis, right? So how we can write? There is no significance difference between, right? Then you can write the other rest of the part. So this is all. This is the each and every time. This is the uh, this is how we have to start to write the hypothesis. How there is no significance difference between, then we can, then here what we have is there is no significance difference between the weight gain from pizza diet and the beer diet. So there we have to write there is no difference. So that is the null hypothesis. Then with that we have to write the alternative hypothesis. There is a significant difference between the weight gain from the pizza diet and the beer diet. Is it clear how to write the null hypothesis and the alternative hypothesis? Right? So you keep that in your mind. So then we are writing for the few occasions again. Then after that, you have any problem, ask from me, then I can explain. We have to start with this uh, by stating this hypothesis, null hypothesis and the alternative hypothesis. Right. Then it is mentioned how we can, this is how to calculate manually, so you can read it and understand. Right. So we can go for how we can calculate using SPSS. Right. Right. Okay. Step by step, it is mentioned how we can enter the data to the SPSS file. So then, if it is independent sample t-test, that data is for the independent samples t-test, there is speciality of actually entering the data. If we didn't enter the data correctly, so we can't uh, do this analysis, right? Then here, look at, there is only one variable, dependent variable. What is the dependent variable here? Weight gain. The independent variable is pizza diet or beer diet. And there are 10 participants, person's ID. So the first variable is person ID, that is a nominal variable. Then I took another variable called diet. So then I defined here, one is for pizza diet and two is for beer diet. Okay. Then weight gain, that's a scale variable. Then I can enter. Then these first five, 1, 2, 3, 4, 5. First five is for what? Because one is pizza diet. Then one is pizza diet. Then weight gains I can add in kilograms. Then two means beer diet. Then again weight gains. Right? That's how we have to enter the data, not to the two separate columns. So you can add for one column pizza diet, for another column beer diet. Then you are in a trouble when we are doing analysis because you can't analyze like adding like that. So the one dependent variable, it means weight gain should be in one column, right? Weight gain should be in one column. Then diet we can change pizza diet to uh, pizza diet or beer diet. Okay. Right. Now we can do the analysis. Right. We can do the analysis. So we are going to compare using a t test. And we have two independent groups. One group is drinking beer, the other one is eating pizza. Right? Therefore, we can go analysis, analyze, compare means. Right? These are the steps. Analyze, compare means, then independent sample t-test. Analyze, compare means independent sample t-test. We can go to the independent sample t-test. Then our test variable is weight gain. That is the output, weight gain. And grouping variable. Grouping variable means there are two groups. One is uh, pizza diet, two is beer diet. Therefore, then I have to group according to the diet. So therefore, I will select this diet as the grouping variable. Then we have to define groups. One is number one for pizza diet, number two for beer diet. Now it's okay. One, two, I defined as groups. Then we can hit okay. Then we will see this is the output. This is the output. At the beginning, it mentioned some descriptive statistics, mean, median, standard deviation, those things, right? Then the important thing in here is, then this is the independent sample t-test results, right? You can see means mentioned there. Here, pizza diet mean is 2, beer diet mean is 4. We can see there is a difference actually. So we have to check this difference is significant difference or not. That's why we are using this t-test actually, this independent sample t-test. Right, then now the thing is that after taking this table, so we can copy those tables. I took that table for here. Right, these are the tables actually. Right, these are the tables. Right, and we have to find the p-value. This is p-value is this one, significance two-tail value. What is this value? Significant. What is this value? 0.02. The value is 0.02. Right, value is 0.02. Then we can take 40 from this one. This is actually the table. Then we can take the p-value. This is the p-value that is in the table. What is the p-value here? P-value, you can see that is 0.02. Here you can see, check. 0.02 is there. Analyze, compare means, independent sample t-test, weight gain. Okay. Yeah. So then this is then what is the p-value here? It is assumed equal. P-value means this value. Significant two-tail value, that is 0.02. Right? 0.02. Right. So the 0.002 value 0.002. It is less than 0.05. So remember this decision rule always. Make a decision rule. Right? So if P is less than 0.05, P value means may have a value, right? The value we found is the P value. There, here 0.002. If that value is less than 0.05, we can reject the null hypothesis. If it is greater than 0.05, we have to accept the null hypothesis. Reject or not, accept a null hypothesis is considered according to this decision rule. If the value is less than 0.05, we have to reject the null hypothesis. If the value is greater than 0.05, we have to accept the null hypothesis. In this case, you can see 0.002 is less than 0.05. So therefore, decision rule, if it is less than 0.05, what we need to do? We have to reject the null hypothesis and act in favor of alternative hypothesis. Then we can go for the conclusion actually. Yeah, we wrote there is no significant difference between weight gain of pizza diet and the beer diet. Right? Pizza diet and the beer diet. Now, uh, statistically, the result is, the final result is for uh, reject the null hypothesis, right? Reject the null hypothesis. Therefore, we can write after writing this since p less than 0.05, we can write reject null hypothesis. And that's not enough. Then we have to write the conclusion. What is the conclusion? Since we reject the null hypothesis, we have to go for the alternative hypothesis. Then we can write the final answer. Final answer, right? So final answer we can write there is a significance to. Then final answer should be like this. We can write there is a significant difference between. This is the final conclusion then. Right? This is the final conclusion actually. There is a significant difference between weight gain from pizza diet and the beer diet. Right? That is how we can apply independent sample t-test. Any questions? I think no. Hmm. Right? It is mentioned step by step here. P value is, t value is, we can take this value. Then p value, probability value, exact probability is 0.002. This is below 0.05. That is less than 0.05. Therefore, we can conclude that participants of beer diet gain significantly more weight than pizza diet because there is a difference. Any questions so far? Right. Then the next example for the independent sample t-test. Example 2. Example 2 for this one. Right? Data set we can take. Example 2. This is the example 2. Then we can perform this one and we can take the output. We'll see. Now you know if we have the reference number, then there are two independent groups, right? Smoker. The groups are here it's mentioned. Smoker. If he is a smoker, yes. If not, no. Right? It is added to this data set. You can see smoker 1 and days. Right? Then we need to write the null hypothesis and the alternative hypothesis. Right? But the question is not clear, therefore we can't write this null hypothesis and the alternative hypothesis. But we can do the analysis part. Right? We can do the analysis part, therefore we can go. I have to analyze this one, therefore analyze. Compare means independent sample t-test. Now our test variable is this days. Then grouping variable is smoker. So it mentioned 1 and 2. As previously we have to define the variables 1 and 2. Continue. Then okay. This is the output there. This is the output. Then here you can say significance value is 0.017. 0.017. That is less than 0.05 at 0 point, yeah, then we have to reject the null hypothesis. That is our conclusion. Right. Second type is paired sample t-test. Paired sample t-test. There are many names also as theoretical dependent t-test, repeated measures t-test, or within subject t-test. So all the names are for the paired sample t-test. Example, a fitness program is developed for obese people. Each participant's weight gains was measured before and after the program to see if the fitness program is effective in reducing their weights. Right? So we can write. So that is actually the experiment. Right? There is a fitness program. Then before the program, weight is measured. Then after the program, again weight is measured. So they have that this time of researchers want to identify whether there is a difference between these two weights. It means then we need to check about the successfulness of their programs. Right? Therefore, we can write the null hypothesis. I think now you have the idea how to write. There is no significance difference between weight measured before and after the program. Right? That should be the hypothesis. There is no significance difference between the weight measured before and after the programs. Then we can analyze. Right. I think you can see this data table. Right. Then weight before is there, 145, 116 likewise. Weight after the program is also there. Then to this research, we have to write a null hypothesis. Right. What is the null hypothesis? There is no significant difference between the weight measured before and after the programs. Right, the alternative hypothesis, then there is a significant difference between the weight measure before and after the programs. Right? Then we can perform the paired sample t-test. The performing tests are not the very difficult task. I told you to identify the test and enter the data is the most challenging part. Then now we added, now this is weight before the program, when weight after the program, we are adding to the separate columns here. Right? Not like the previous one. So to perform paired independent sample t-test, so there is a specific method to enter the data to the SPSS file, as well as for this one also same, right? Therefore, now we have to add the data to the two different columns, weight before and after the programs. Right, then you can go same process, analyze, compare means. Now earlier we selected independent sample t-test. Now we need analyze, compare means. Now we need not independent sample t-test. I need paired sample t-test. Paired sample t-test. Then this is weight before, weight after. Then we can check weight before to weight after. That's all. then okay, right? Then values are there, tables are there, right? T value we can take from here, this one, 0.751. Yeah, T value is 0.751. That's okay. Then significance level is decided by the researcher. Here, that significance level is set to 5%. It means 5% errors can be happen. Those are right. So, when we are doing a research, we can take 100% correctly things, right? So then we have to check this paired sample t-test actually. So the significance value is this one, 0.472. 0.472, and this is greater than 0.05. It means we have, if it is greater than, we cannot reject the null hypothesis. If it is greater than 0.05, we have to accept the null hypothesis. Then that is our final decision then. Accept the null hypothesis. Okay, right. Here, step by step, everything is explained, right? You can check later, right?
Excuse me, sir.
Yeah,
So I have a small doubt. So in that
yes.
you said that the significant value, if it is greater than 0.05, it occurred by chance. We consider it like that, you know. We are rejecting we are accepting the null hypothesis. So the research occurred by chance. So my problem is how you said that, yeah, the researcher is the t value is it's how the researcher is choosing the t value. Like, that's my problem.
P value.
Not the p value, not the t value.
P-value, yes. That in normal cases, right? Yeah, that's again a good question, right? So normal researchers, right? So there is an error. Research. So when we are doing any research, there is an error. So that we called. So there are two types of errors. One is type one error and type two errors, right? So if you need to know these things very deeply, so you can read a book like. Yes, there are some books wrote by Creswell, some others also, right? So you can read about that. So then here clearly mentioned. So then there are some sampling errors. So we are considering that sampling error. Sometimes if we done our research very accurately, so we can take the error as 1% sometimes, right? That is decided by the research actually. So sometimes we can take it as 5%. So if it is more than 5%, we are not taking. The normal case is 5%. So therefore, if it is 5%, 5%, if we converted that 5% into the decimal of 5 over 100, it is 0.01, right? So then that is the p-value for if our confidence level is 95%, or our confidence interval is, our error rate is 0.05. So we are compare with 0.05, right? So if you have confidence, right? If you have confidence, you are doing your research for the 99% accurately. So then we can select our p-value as 0.01. I think you are asking about this comparing number, isn't it? You are asking
Yes,
how
yes.
this
Yes.
zero
It's
point
about
0,
the p value, not the
this
p
one,
value. No?
right, this one, no,
In,
this
yeah,
0.05, you are asking
yeah,
how
in
this
that the
0.05 is taken.
SPSS no, that in SPSS window when we were doing this paired sample t-test, you talked about the t value or the p value. The researcher decide the p value or the t value. I was asking.
No, we are not deciding any values, right? P-value is given by the test, right? So you are asking how to find the p-value in that test.
Yeah,
Yeah,
no, like
in
I'm
the
asking
table.
like
Yeah,
yes.
yeah,
So
it
it
is.
depends on the confidence value, like it's how it
Here.
like how
Yeah.
confident we are. Okay,
Yes, so
thank you.
significance level here then in this case I consider this significance level is 0.05. Then that's why we are comparing it 0.05. If we select that our significance level is 99%, it means 0.01, right? So we have to compare with that value, right? But decision rule is same, right? So our p value is given by the output, Yes, this output is given the p-value. Here
Okay,
you
sir.
can see the p-value is 0.472, right? 0.472. It is given by the output, right? 0.472. Then we have to compare with this 0.472. This is 0.472 by this significance level. We decided it as 5%. Most of the times we are taking this as 0.05. So then based on this value, p-value is given in the output, then we are comparing with this 0.05. Whether that if this is less than 0.05, we have to reject the null hypothesis. It means there is a difference, right? If it is greater than 0.5, is in this case, so that is greater than 0.05, then we have to accept the null hypothesis. Always we are writing the null hypothesis, there is no difference. No difference means our uh, program or our research is not successful. It means it is not worked well, right? So then we can conclude it. So if it is reject the null hypothesis, it means if you got the value less than 0.05 for this p-value, so we can reject the null hypothesis. It means our research is successful, right? So sometimes sometimes we are not obtaining the results as we expect. So in that cases, we are taking the p-values greater than this 0.05. Then we have to accept the null hypothesis in that cases, right? Is it clear?
Yes, sir. It's clear. Thank you.
Okay, okay, right. Next one is yeah. This is again described in your slides, right? So you can read it again with the outputs, with the screenshots. Everything is mentioned there as then I showed you how to do it and how to select these p-values. Everything is in your presentations, right? So you can read it. Then last type of t-test is uh, one sample t-test. So that is actually I told you that one sample t-test is compared with the hypothesized value or a constant value, right? Sometimes that constant value is population mean or something. For an example, this is the example. A principal school A wants to know her fifth grade score differently on the math test than the fifth graders in school B. A principal wants to compare math marks of his own school from an math marks from another school, right? So it means we can find the mean maths mark of each school, right? Then if he wants to uh, compare that with the value means the mean marks of the other school. So then in that case we need to go because that is a constant value. That mean mark means a value. Then in that case we can use this one sample t-test. The other two types are not valid in that case, paired sample or independent sample t-test, right? Then how we can write, then she knows the fifth graders of school B's have mean of 88 on the test. So the mean of that is 88. Then this is the constant value actually. Then we can write the null hypothesis and the alternative hypothesis. How we can write is there is no significant difference between the sample mean and the population mean or the mean marks of school A and school B for this one, right? Then we can perform the test after writing the hypothesis. So we can perform the test. Again, we can go for analysis. Yeah, we can go analyze, compare means. Now we have to select. Earlier, first time we selected independent sample t-test, then we select paired sample t-test. Now we need one sample t-test. Then test variable is mat test. Then test value is 88. That is the hypothesized value. Then okay, that is all. Then we get the output. We have to take the significance to tail value, it is 0.544. we can find the value is 0.544. 0.544 is greater than 0.05, right? Therefore, our conclusion is we cannot reject the null hypothesis because that is greater than, then we have to accept the null hypothesis. It means, so we thought that, so principal ones, then there is a difference, right? There is a difference. Sorry, there is no difference. වෙනසක් නැහැ. ඇයි? We have to accept the reject කරන්න වෙනසක් වෙන්නේ. අපි ලියන්නේ මොකද්ද? Null hypothesis. There is no difference between two groups. There is no difference. Then no, there is no difference. It means this is just quite equals to 88. එහෙනම් 88ට සමානයි වගේ තමයි. Right? So these are the three types of t-test. Occasionally, you have to use these three types according to your research objectives and the types of data you collect. Right? Any more questions about t-test? So I will give you again a tutorial. So with practical questions, right? As I did for descriptive statistics. Then you can, after this session, you can try it in your, uh, try in home before next day. Then again, we can discuss it with your problems, right? So you have to identify which test is appropriate for which situation. That is the most important thing to choose in the type of t-test. Right. Any more questions related to t-test? Yeah. Okay.
Uh,
Then we, yeah,
uh,
yes. Yeah, Bharti.
in a clinical research perspective, so like let's say we are doing a research with collecting a sample and analyzing some values and not without recruiting a healthy control. We
Uh,
are analyzing a sample from a patient and we are just checking it with a reference value from internet or something. We are just going for
yes.
the one
Yeah.
sample treatment.
One sample, yes, exactly correct. It means you are collecting the blood pressures of a person, right? So then that that normal, there is a normal value for the blood pressure, sometimes systolic, and I don't know exactly that is what are the medical terms, right? So anyhow that, so suppose that is 120 or something. So if you are checking with that constant value, it means that there is an accepted value. So in that case, we have to go for one sample t-test. Yes, that's true. Okay. Right. So here it is again, yeah. Then ANOVA, right? Now we discussed about how to compare the means of two groups. T-test is applicable only for two groups. If there are more than two groups, we can't go for uh, t-test. In that case, we have to go for ANOVA. ANOVA. If there are more than two samples in your research. So we have to go for the ANOVA to check the mean difference. ANOVA means this analysis of variance, right? So ANOVA means analysis of variance. ANOVA is analysis of variance, which is usually shortened to ANOVA. Is the most commonly used statistical method for testing hypotheses about three or more means. It may be there are if there are two means, we can go for t-test. If there are three or more, we can go for ANOVA. The ANOVA statistics test is called the F-test after developing by Fisher. Fisher has developed this F-test, right? So again, the process is same, right? The only difference is if there are more than three means, we can go for the ANOVA, right? Then here you can see mean 1, mean 2, and mean 3. There are three samples, right? Here it's mentioned how to calculate this. Yeah. Just read those things. This is how you can calculate using manual formula. So we will go for the SPSS. I told you this is given for your knowledge, right? Read and understand. So if you can't understand things, omit it because we are doing this using SPSS. So if you are interested in solving mathematical problems, so if you need to learn further, it's mentioned there. Yes, right. you see, this is again manual calculation, right? Manual calculation. But I will read the example because this value is, I think, yeah. Wait, I will check my example, which is taken to the ANOVA. Yeah, this is the example. Therefore, we'll read the example, right? Then we'll go, maybe omitting that manual calculation part, we can go for mm, SPSS. So this is the example. Evaluation of training programs. Goal is to see if there is a significant difference in learning time using different training methods, right? So there are two variables here. One is training method, the other one is learning time, right? So then therefore null hypothesis, there is no significant difference between uh, training methods, and alternative hypothesis should be there is a significant difference between these training methods. So these are the data actually. There are here, I think there are three training methods. Yeah, sorry, four. Method A, B, C, and D. So we have to check whether there is a difference between these four methods, right? Okay, so then here it mentioned how to do it manually, right? We can go, yeah, yes, SPSS for one way and another, right? SPSS for one way and another. So then therefore we wrote there is no significant difference of different teaching methods. Then method A, B, C, D, right? As we entered data to the independent sample t-test, right? It means we have to take method for one column, called method A, method B, method C, and uh, method for one column and learning time for the other column. Then there are only two columns, right? There are actually four groups here, but we are taking only two columns to add the data. One is method. Then we can define method one, method A, method B, method C, method D to 1, 2, 3, 4. And the other one is learning time, right? So here we can enter the data. So then there are two variables there. Yeah, there are two variables. One is training time. Sorry, one is training method. Training method, we can add method 1, 2, 3, 4. Then 1 for method A, 2 for method B, 3 for method C, and 4 for method D. And the other one is learning time. Therefore, we can enter the data like this. For method 1, these are the learning times. Method 2, these are the learning times. Method 3, and method 4. Likewise, we have to enter this data only for two columns, not method A, method B separately for the four columns. If you take like that, so you can go for this. You can't go for this analysis and over because the way of entering data is wrong. Right. Then yeah, it's mentioned how to do this one. Right, step by step we can go. Right. Mm, then we can go for one way ANOVA. Right, one way ANOVA like uh, performing t-test. Again, method is same. Analysis, process, compare means. Now we have to select one way ANOVA. One way and another. Then again, dependent variable is learning time. Then training method is the factor variable. Okay, so we have to take that. Then we can go for the options here. Options. In the options, we can take this descriptives and homogeneity of variance test. I will explain what is that test. So if you need, there are some more mean plots, those things. Then continue, right? Then we can perform the homogeneity of variance test. So we can go for the post hoc test. Post hoc test. Right. Again, I will explain. Then here there are many post hoc tests. And in this example, We selected three post octets. There are many, right? At least if you used one is also enough, right? Continue. Mm. Then we can take the output. Okay. Then output is performed here, right? So then it's descriptive statistics is here. Then mean, standard deviation, standard error, everything is there. Method for each and every method. For method A, mean is 9. Method B, mean is 12. Likewise, it is represented the descriptive statistics. The other one is, yeah. So, right. So then we can take the mean, standard deviation, and other descriptive parameters given in this descriptive box. This one, right? So it is given. And test of homogeneity of the variances. P-value is indicating the equal variances. So variance should be equal. So then homogeneity of variance test is given there, right, based on the mean. So we have to check this value, 0.229. If that value is greater than 0.05, with 0.05 volt value. If it is greater than 0.05, it means that there is an equal variances between these groups. So therefore, we have to check this value whether this is greater than 0.05. Only we can say that these two samples actually A, B, C, D has equal variances. Right. Next we can go for the ANOVA table. That is the main result actually. ANOVA tables is this one. Then we can check for significance value. That is 0.02. Significance value is 0.02. Then 0.02 is less than 0.05. So our null hypothesis always we are writing. There is no difference between these four teaching methods, right? But here we got the value as 0.02. It is less than 0.05. Therefore, we can reject the null hypothesis. We started by saying there is no difference between teaching methods, but we can conclude because since this is less than 0.05, so we have to reject the null hypothesis and accept the alternative hypothesis, right? Therefore, we can write our conclusion. We have to reject the null hypothesis. Then we can conclude there is a difference between mean learning time scores with the four different teaching methods. So that is the final conclusion, right? Now here we can't stop from there because why is that? So there is a difference. But in that case, so then there are four groups, A, B, B, C, C, D. So therefore we have to find whether then we found that there is a difference. Then we have to find where that difference is. That's why we use this post hoc test, right? Post hoc test for that purpose, right? Right. This is post hoc test result. This test is Turkey. Yes, this one, Turkey HSD test. I added three tests for here, right? Then it's mentioned the relationship between method A and method B, method A C, method A, method D, likewise, right? So difference is there. So therefore, and also homogeneity subsets, last one. Then it is divided into groups, subset 1, subset 2, right? So this is mentioned here. Homogeneity subset are separate teaching methods four from other methods. Look at this one, homogeneity of subset. Now, what is our conclusion? We started by writing there is no significance difference between these four teaching methods. But statistically, we found that because statistical significance value is 0.02, it is less than 0.05. So we can conclude that there is a difference actually. We can't say there is no difference, right? We can reject the null hypothesis and accept the alternative hypothesis. Then in this homogeneity, in these tests, post hoc test and the others, what we are doing is we are finding where this difference is. So you can see here, if we consider these homogeneous subsets, method A, method C, method B is one column and method D is in another column, right? So then this homogeneity subset is separated the method B for another column, right? What is the meaning of it is, then we found that there is a difference, so that difference is with that method D, right? That's why we can conclude here, right? If we looking to this table also, we can take here the that one, right? Okay, you can see here these flags, right? The mean difference is significant, right, for this one, right? So likewise, so the most it is easily identified by this homogeneous subset, these three in one group and this is in another group, right? Homogeneous subset separate teaching method 4 from the others. 4 is separately to another one, right? When we report the outcomes of the ANOVA, we cite the value of F ratio. On this case, there is a significant difference between the learning time scores for teaching method 4, right? Why it's mentioned it as teaching method 4? Because we found that there is a significant difference, but that difference is in the teaching method 4. Why is that? The other three in one set, that is goes to another set. It means teaching method 4 is different than the others. So therefore, we can conclude there is a significant difference between the learning time scores for teaching method 4 and the other three methods tested. So then these are the values. Right. Mm. With that, I am that a very simple thing that is Anakova. So we'll discuss that in next day. Right. Then I want to show you today's tutorial. Right. And I have to ask some questions because if you cannot understand that properly, you can't do this analysis because that is the important thing. Key test questions. Right. Read the first one and tell me which test is appropriate for this case. A researcher is interested in gender differences in cortisol production, a measure of stress reactions under conditions of sleep deprivation. Participants were asked to stay awake for 24 hours, after which their cortisol levels were measured. Discuss how gender may influence cortisol levels and analyze the given data to determine the significance difference. Right? Likewise, there are some questions. So this is the incident. So my question is, which test is appropriate uh, for this instance, right? So if you have this kind of research, so what is the test you are going to use to check whether there is a difference between this uh, then it's the researcher interested in gender difference in cortisol production. Yeah, what is the appropriate test here and why is that? Yes, Prarthana, which one is
Maybe we can go for an independent sample T test because we are comparing it between male and female.
yes, exactly correct. Because here there is two groups. One is uh, male, the other one is female, right? So therefore, there, we can separate into two groups. Therefore, definitely we have go for the independent sample T test. Yeah, that is the thing I wanted to give you because if you didn't understand that question properly, so it means that analysis is not a very difficult thing because after enter the data to the package, it will find the values, right? Second one. Amila, I'm asking from you this question, right? Consider a study in which systolic blood pressure was measured in two different positions, standing and spine. Uh, the study was conducted on 12 subjects, which their blood pressures recorded in both positions. Evaluate whether the changes in posture has the statistically significant effect on systolic blood pressure. Right. Which test is appropriate and why? Amila, Prarthana, can you give an answer for this?
So we are checking it in standing and supine position. So I thought like maybe a pre and post test. Are we considering it as a pre and post test?
Sorry. Yeah. So, okay. So then, what is uh, the
I
difference?
think
Sorry, what is
primary
the test?
sample, paired
Yeah.
sample
This is,
test.
yeah, this is actually not a pre-test post-test, is actually I given you as an example, right? So then what is the instant we have to use for using that paired sample t-test was that so we have to measure two times of a same group of persons. Same person, we have to test two times. Right? In that case, we have to go for the paired sample t-test. Then here, subject one, person one is measured twice, right? Measured twice. Every person is measured twice individually. Therefore, in that case, we have to go for the paired sample t-test. Pre-test and the post-test is an example actually, so that it is easy to remember. That's why I given you. It is not means that always the research only we have pre-test and the post-test used to this find this to analyze this paired sample using this paired sample t-test. Third one, agricultural researchers collected by rice yield data from two different farming areas to examine productivity differences. Analyze the dataset provided and discuss whether this is meaningful variation rice yield of these two locations. What is the test? Prarthana, you is on only you is available. Others are not here because most of the people are referring to this video, right? So there are many participants here, but only few active participants.
So in this
Prarthana,
we are, yes, I'm not clear about the question.
yeah, then there are, look at here.
Yeah.
Agricultural researcher collects rice yield data from two different farming areas, right?
Mhm.
So, yeah, then whether there is a meaningful variation in rice yields between these two locations, two different farming areas, then the purpose is uh, to find the variation in rice yield between these two locations. Then,
Maybe for one sample t-test, which is
no, why we can't use one sample t-test here? Why is that? There is no exact value here. So nothing
yeah.
mentioned as exact value there. Yes.
Mhm.
So then you
We
can
can't
say,
go for a independent t-test because like it has to be two groups, like two different farming
yeah,
areas can.
there are two groups too. Why there is not? Then area A is one group, area B is the other group.
Oh,
And the
okay.
rice yields are
Okay.
there. Yeah, then this is what? Independent sample t-test.
Independent. Yeah.
Yeah. Yes. Next one. A teacher wants to assess whether her introductory statistic class has sufficient grasp of basic mathematics. A random sample of 6 students was selected and their scores on math proficiency tests were recorded. The teacher expects the class to have an average score above 70. Evaluate whether this exception expectation is supported by the data at 90% confidence interval. So then what you can say, what is it?
You have to go for
That
the one
is
sample.
here
One
one sample
sample.
details, right? Okay. So then that is the thing. So you have to identify which ones. There are some more questions. Because we discuss about all three types of details. Then another is there. This another tutorial. This is also given in this one. This for the method. There are three methods. Then you can go for ANOVA, right? In this question, don't do fourth one, right? This is for ANCOVA. I didn't discuss today. Then here you can do only three of this second tutorial. That is ANOVA and ANCOVA. Yeah, don't do fourth one because it is not discussed yet. Yes, right. So then, before coming to the next class, so you have to do these two tutorials that we'll share with you, right? And yeah, that's all. Any more questions? I have asked from Prarthana only because you use only the
Yeah.
active person.
Okay. Yeah.
No, right.
That's
Okay.
right.
Then, yeah. Then next day we are going to do another test like regression analysis, correlation analysis, those things, and the other one is chi-square test as well. Right. With that, then we can finish for today. Then we will meet in next time. Right. Good night.
Thank you, sir.